My name's Kevin McQuiggan, and I'm going to be talking, giving a short talk on using GNU Radio to introduce digital radio concepts to amateur radio operators. By amateur radio, I mean ham radio. And so, first thing I'll say is, man, oh man, it's tough to have the first talk after lunch because people are usually sleepy and that kind of thing. But hopefully, we'll make this a little bit interesting for you. So, how many people here are amateur ham radio operators? Great, yeah, so it looks to be maybe 20% or so. I missed the conference last year, but I was here 2 years ago for GRCon18, and it was about the same. It was about 20% or so. And so anyway, for the ham radio operators, please bear with me. I just want to talk a little bit about the background of ham radio, and then we'll go on from there. So amateur radio, it's an international activity. It has a history. It's been around for over 100 years, and really what it is, the essence of amateur radio is that it is government-sponsored experimentation. It's government-sponsored experimentation in radio. It is a licensed activity, so the standards are set by each nation based on international standards that are set by the International Telecommunications Union. And so there are different specialties. And let me also say, this is not a technical talk. This is more along the educational thread and using GNU Radio for learning and things. And so the activities within amateur radio can really be divided into two different types. They're operational activities and technical activities. And I think on the operational side, it could be disaster response, emergency communication, emergency preparedness, message handling, that kind of thing. And then on the technical side, I would assume everybody here who's a ham has interests on the technical side. That's more electronics, antennas, propagation, and things like that. And so certainly that is my background in terms of amateur radio. So the motivation for amateur radio operators is really, it really started out, in the days before the internet. It was the excitement of being able to have unmediated communication with other hobbyists anywhere in the world. And also motivation for a lot of people was technical skills, technical learning, and also, innovation within the radio sphere. And the advantage, so you think, why does government support amateur radio? Well, governments support amateur radio historically because what they're able to do is they're able to support technical training among citizens, among people of their nations, and then called on by the military in the event of war. And if you go back to the Second World War, for example, there was a large draw on the amateur radio community by the military in many nations. They were a source of radio operators and technicians and that kind of thing to support the war effort. And so internationally, governments have an interest in supporting amateur radio. Now, amateur radio, it's a licensed activity, and so amateur radio operators have to be licensed by their governments, right? And so the licensing consists of many components: technical qualifications, operational, and legal. The impetus for this licensing is to ensure effectiveness of communication, but prime in that is non-interference to other services, because amateurs have a number of frequency ranges, frequency bands on which they can operate. The government's very concerned, said we have to put regulations in place, we have to put licensing in place to make sure that the amateur activity, this hobbyist activity, experimental, innovative activity, doesn't interfere with commercial services. So the examinations in the 2000s, in the current era, they focus more on legal and operational aspects than on technical details within amateur radio. For those that have been licensed for many years, and I have a slide on my background, I've been licensed since 1977. The emphasis in the training and the qualifications used to be much more on the technical side. And the legal component was always there, the operational component was always there, but there was much more emphasis on the technical side of the training. And that's reversed, starting about 20, 30 years ago. And currently now, the training focuses on the legal and operational aspects. So the technical training is based on international ITU regulations. And the foundation of this, and now we're getting to why is GNU Radio, why am I here, why am I talking about GNU Radio? And that the foundation of the technical specifications, the technical standards, and the technical training all over the world is based on analog theory, analog circuits. And within the amateur community, we've seen slow adoption of digital concepts such as STR into the national standards. That is not to say that amateurs aren't involved in digital modes like, digital modes of various types and everything, but in terms of the national and international standards, they still focus on analog capability. And so we should talk a little bit about amateur radio and innovation as well. There's significant history of innovation within amateur radio. Examples would be go back to the 1910s, 1920s, amateur contribution to propagation theory. Early single sideband was largely pioneered and experimented with by amateur operators. There's a mode called SSTV, slow scan television, that was pioneered on amateur radio frequencies. And in the modern day, amateurs were curious. Amateurs love to innovate, love to create new technologies, put existing technologies together in innovative ways. And so amateurs today, right, they retain this curiosity, retain that innovative spirit, but what the situation is that they lack the current technical fundamentals to fully understand new technologies like DSP and SDR, right? And so, and experiment with them in the amateur radio space. And so the reason they lack these technical requirements is because they're not part of the standard, so they were not tested, they are not trained in this area. Anyway, I should say on the positive side, amateur radio, very, very positive activity. It does support public safety, valuable operational resource in the event of earthquakes and hurricanes and natural disasters, even community events. Amateur radio does do a lot of positive stuff. However, on the technical side, the knowledge gap between the ham's licensing requirements and technology-related topics, it's become very, very wide. So, and on a technological basis only, the hobby really remains stuck in a communications paradigm of the 1970s. And so the hobby is trying to modernize, but really there is a huge, huge gap compared to, for example, when I got licensed 40 years ago. I've been licensed, as I said, 1977, did some research in this as part of grad school for me, wrote a thesis on innovation in telecom technology, specifically in amateur radio. Been teaching for 40 years and former lead instructor for amateur radio training classes over the last 20 years or so. So amateur hobbyists, they have strong interest in digital techniques and SDR, but they have no mandated training, as I said, little technical understanding of how it works. So this undermines some of the national objectives for the hobby. Of course, the government wants to maintain a cadre of experienced, technically capable people, and that sort of undermines the usefulness of the hobby for our national governments. Interestingly, amateur radio equipment, and there are specialized manufacturers of amateur radio gear, they have moved forward, of course, with digital radio, SDR, that kind of thing, and with very few exceptions. The manufacturers, everything's digital, everything's SDR behind the scene, but they put knobs and dials and switches and that kind of thing. So because the users are used to that analog front panel, right? We have this digital radio that has all these, I think on one of the latest amateur radio, one of the latest gear, I think there are 100 controls or 120 controls or something if you look at all the options and everything on the front panel. Far easier just to, it's software behind the scenes. But the users are used to this analog user interface. And so GNU Radio, it's a useful, it's a fantastic, GNU Radio is a fantastic tool for introducing SDR techniques, digital radio to amateur radio hobbyists. They have basic analog-based technical understanding of radio. So my idea was to offer an introductory SDR program for licensed hams, for licensed amateurs. In order to raise the technical literacy, because they have an interest in it, but they don't have the background for it. And so in 2017, 2018, I live in Vancouver, BC, the western side of Canada, offered 4 classes offered in this in the last couple of years. So the reason I'm here is I thought, hey, I'll come and talk about it, how that went. And so the course philosophy. What I wanted to do in this is I wanted to reduce the apprehension of the students about complexity, because everybody realizes all hams say, oh, DSP, SPR, SDR, very, very complicated. How could I ever understand that? And so I want to introduce digital techniques, DSP, through comparison to better understood analog processing. And then have the students apply this new knowledge to build a digital receiver using GNU Radio Companion. And so the overview of the course, it's 4 hours in length. It's a lecture, demonstration, and hands-on, and big on the demonstration and the hands-on. Students were required to do 2 things, I guess 3 things, to have an interest in it and sign up for it. Purchase an RTL dongle, the cheap $15, $20 that you can get on Amazon. I'm sure everybody's seen them. and bring a copy or USB, bring the ISO that has the GNU Radio live environment on it. And so, we'll talk about the course a little bit. It's a short intro to digital radio. It's a soft introduction to DSP, FFTs, IQ, all that. And I'm the first to say, my background's computing science and math. I understand this stuff fairly well. I am nowhere near the level of most of the people in this room and everything, but I know enough to be able to explain it, I think, and give soft introduction to this. The reason it can't be a technical course, it will be a technical course that will drive the users away because they're already coming with some apprehension that this is going to be complicated, right? And so we have lots of, use the whiteboard, have lots of interactive discussion. And so on the right is a slide from the course that we give, right? And in here I'm talking about how, really the math defines signals, the math defines amplitude modulation, frequency modulation, SSB, et cetera, et cetera. And I just tell them, digital radio uses computers to represent and analyze signals directly based on their mathematical representation. They don't really have to know the details. I do give them some foundation, right, and give some examples on the board and that kind of thing, because they have proven technical ability. The test itself is not, I would say it's not really, really hard, but from the technical perspective, you do have to know something about radio technology to pass the test and get licensed. So they have technical ability, but due to a number of factors, they're going to be threatened by, and they do feel threatened by DSP SDR. So the goal, as I said, reduce anxiety, inspire confidence among the students, despite their age, their background. And I tell them, despite your age, despite your background, if you got licensed 30 years ago, you can learn this. Because you already have basic technical ability, you have the ability to learn from your previous things. And so I focus on comparisons. I compare analog circuitry with digital, and we'll get into that in a sec, but what I say is analog circuitry is simply an approximation to the math that exists behind radio, right? And in the old days, computers didn't exist, computers weren't fast, and so we had to approximate that mathematics using inductors and capacitors and resistors and various circuits and things. However, I tell them, CPU systems now capable of simply doing the math. So you don't that. You can move it all into the digital realm, except for the front end, of course. So I want to build their confidence through soft explanation and give them some easily readable but strong reference material, right? And I'm also realistic with them in terms of realistic in terms of learning. And what I tell them right up is this is not going to be easy. If you really want to understand this, you're going to have to spend a couple of months, 6 months. Theoretically, you could spend an awfully long time to really get up to speed on this. But it's very important to be realistic in terms of saying, yes, this is a tough subject, but if you put the time in, you certainly can understand it. Because that's where I came from. I tell them, I say, I'm no mathematician. I just had an interest in this area. And I read for about 6 months or a year, and I started to understand it. I started to experiment, and I tell them, I'm a success. I can do this. You can do this too. So it's a demo-based approach. Here's an action shot, right? So anyway, what we do is we start with simple flow graphs to start with a signal source and a signal source and an audio sync, right? And run that. Run it, and we build from there and everything. Talk about the flexibility the software-based approach. I do use GNU Radio Companion for this, and give them a basic introduction to the desktop and that kind of thing. Lots of, when we make mistakes, I have them do all this. They make mistakes. They have make mistakes, we correct it. We talk about that's how we introduce the throttle block, for example, right? Because their full graph, hey, my full graph stopped and the screen turned dark, right? And so we talk about the need for all this through demonstration, interactive, whiteboard-based approach. And now a couple of action shots. We had students in the class, and these are all licensed amateurs, from their early 20s through their 70s. This couple here, right? They had to be 70 years old, right? But they're, they've both been licensed, I think, for 50 years or 40 years, 50 years. But they said the characteristic of hams, because hams are curious, the hams here will know, right? Curious, interested in technology, that kind of thing. So even though they've been licensed for many, many years, oh yeah, we wanted to ask them, why are you here? Oh, we're here because we want to find out more about digital radio, find out about how some of this works, right? And anyway, very, very good. The average age of the people in the 4 classes was probably about 50. And I'm thinking I could have changed that, maybe 40 to 50. and everything. But the key there is everybody that comes, they're interested in figuring out what this is all about. All walks of life, people in the picture. You can tell this guy's the engineering student, the young guy, right? But we also have a physician, medical doctor, right? An engineer, computer scientist, locksmith. The guy here is a locksmith, a concert pianist, psychologist, doctor of psychology, that kind of thing. And so that's the character, amateur radio operators come from all walks of life, and they have this, they just have this interest in personal communications. And so what I do is I use all amateurs have experience with high-level block diagrams, right? Filter, demodulator, modulator, that kind of thing. And so I present them with analogies, with simple flow graphs, right? Say, oh yeah, here's the front end, the demodulator, here's how you do a volume control, here's the tuning knob. Relate it to what they know already from the analog world, because they've been exposed to block diagrams, and that provides a good segue to GRC. For further learning for them, I have to take a realistic approach with it. And so what I say is, I don't underrepresent the complexity of the field. Say you could spend years and years learning this. I tell them it took me a year, right? And I read and experimented, and that kind of thing. So students are advised they should expect to spend significant time studying, experimenting, and learning. And so I refer them to quality introductory material. And if I can be specific, I guess, the GNU Radio tutorials, despite, everything could always be better, as we were saying this morning. Right, but generally fairly high quality. Refer them to Wikipedia, refer them to the video series, Michael Osman from Great Scott Gadgets, that were created with HackRF. And then that book, that most people have probably heard of, The Scientist and Engineer's Guide to Digital Signal Processing by Stephen Smith. Because it's downloadable, you can download, and in fact, what I tell them is, I said, I liked it so much, I bought a hard copy, right? And everything. So I give them reference to good material and also tell them, hey, this isn't gonna be an easy road. This is a learning curve. This is something you're gonna have to work, right, if you really wanna understand it. And so going forward, after the course, the students emerge, they will always emerge with new knowledge, stronger understanding of how and importantly, why digital radio works. And I would divide the students after the class into two categories. Dabblers, right? Most students, they just want to learn some fundamentals. They learn some fundamentals, they're likely not going to become advanced users. But then the other one, the adopters, and I've seen 2 or 3 from the classes so far. That is key, because now you have 2 or 3 people that didn't understand, that have actually gone forward, done some reading, done experimentation. One of my students, one of my students called me up afterwards. He's, how do I do this? How do I do that? Right, and he's really, really getting into that. So I see that as being quite a success. So we'll talk about results in 2 different categories. Specific results, the students get several flow graphs. They get a working FM band receiver. I just have them use RTL dongle, 88, 108 megahertz. They're able to receive stations, have a volume control. They understand how digital radio works a lot better. They also get knowledge of how to use, GRC. And hopefully, through this, I've relieved any feelings of intimidation and increased their confidence. Because of course, we all know if you want to learn something, you got to have confidence. You got to say, you got to believe in yourself. And so I try to give them that through the course. So that's specific. But moving back to the big picture and the amateur radio governments and amateur radio international, the ITU and that kind of thing. So this is a small step. This is only 4 classes in the overall picture, right? So it's a small step. But what it generates is increased understanding of SDR, DSP in the local amateur radio community. And the other big picture result, realignment of amateur skills in relation. Yeah, what it does is this supports realigning the amateur skills in relation to the vision of amateur radio as being a global and international resource. Right? So it's a small step, but if everybody did it, we could really increase the literacy within the amateur radio community. So what this implies is that amateur radio regulations, training programs need to modernize. Right, the international standards, it's very glacially slow because of ITU, national governments. It takes an awfully long time for changes to filter down to changes in licensing requirements and regulations. So anyway, those programs need to, the second implication, lack of technological currency limits amateur radio's tradition of innovation. Whereas if you go back many decades, amateurs were responsible for many, many innovative things. That is less now. I think because the field has moved forward, amateurs have to have different skill in order to continue to innovate. And the other implication, GNU Radio can play an important part in the training of new hams. Now, challenges. And we're coming up to the end here. I hope I'm all right for time. Challenges, the need for international and national regulatory changes. Right? Second challenge, disruption of, this is a big one. You know, going this way, we have to disrupt a long-established tradition and culture within a mature hobby. Amateur radio, in many respects, as I said, and I had, you know, public safety, amateur radio does an awful lot of good. It's an excellent hobby. I would never say that it wasn't. But I think there is resistance to change in a hobby that has been around for more than 100 years, right? Things like, you know, and that change has to be generated within the community itself, and a lot of people are complacent, right? They become complacent in what they know and what the hobby should do and what is, you know, and that kind of thing. So that will, I think that'll, so that is a challenge in terms of changing the culture within the hobby. And the third challenge, I think, is lack of sufficient DSP, SDR knowledge on the part of existing instructors in amateur radio classes. Right? I think if we can, it should be, I think it would all be generated by changes in the regulations, but if the regulations, even if the regulations were not changed, right, you have to generate understanding of DSP, SDR within the instructor community. And then the instructors be able to pass that on effectively to students. And now it's not taught, because the instructors don't have experience in it either, and they don't have experience in it because it's not mentioned in the regulations. So with that, I just wanted to give an overview of these courses that I presented and everything. I'd be willing to, be very, very happy if anybody has any comments or questions. Oh, thank you. Thank you, sir.
You focused on transitioning folks who had an analog radio background to digital radio. How was your success in transitioning folks with a computer science background to digital radio? So that's where I came from. I'm relatively new to digital radio, coming from a strong computer science background.
I think it is always easier for people, like when I showed the group of students, the engineering student, his computing experience, it's easier for them because they have this experience in that realm, and they just have to absorb the new the specific knowledge in relation to radio and everything. But all that said, I think because it is not inherently computer-based, it's more just thinking about digitization and thinking about DSP and that kind of thing. I think everybody can do it, but I think the people that certainly, to answer the question, yes, the people that do the best are those that have like the engineering background or computer science background.
And are you able to share your content?
Oh, the content, certainly.
Okay.
Certainly, yeah. It's on, so what I would do, contact Derek or something, and I can share the presentation.
Thank you.
We can easily attach it to your presentation as part of the program website.
Yeah, I can, I'll take another question, but anyway, just a comment in that area is that I think in a sense, amateur radio groups, they have missed an opportunity because of the maker movement. Right, we're all familiar with the maker movement and young people, generally young people creating and innovating, all that sort of stuff. Those people, the young people doing that is fantastic, but they don't have experience with radio. And so I've seen a number of cases where the makers, they're doing something with wireless, and I need to build an antenna, and my antenna doesn't work. How can I get better? How can I get better gain, or how can I get better directivity? And what they're doing is they're stumbling around in the dark and reinventing things that amateur radio solved 100 years ago. If the amateur radio community had seen, rather than a threat, they see that as an opportunity, they could go to the maker movement. They could say, oh yeah, this is how you make, you're going to need a Yagi antenna. A helical antenna would work well here. This is how you build it, right? Because we did this 100 years ago. And so that is when I talk about the mature culture, resistance to change within amateur radio itself. And all that said, I'm not running down amateur radio. It's a tremendously positive activity, but it just needs to modernize.
Do we have other questions?
Marcus.
So actually, I should have thought of you earlier this year when I was actually preparing to hold exactly a seminar for ambitious hams in Switzerland, and into an introduction to SDR with GNU Radio, and it turns out that those guys were mostly engineers. So. Yeah. That was pretty easy because all of them, like, they had math that far exceeded like high school level.
Yeah.
So that was rather easy. But somewhere in the first 2 hours, I had a 6-hour thing, and somewhere in the first 2 hours, well, I've lost a couple of people. How do you like deal, like the math at some point gets more involved, right? You say, okay, we have to sign, we have to cosine, we can maybe project onto these, and people get the idea that these are two signals that are like independent from each other, and you build up on that. But at some point, you lose some people, also because like there's different speeds in how good, well they prepare to use their computer and this kind of thing. So how do you deal with learning at different speeds in your seminars?
Yeah, what I did is I tried to I touch on the basics. I talk about signals can be represented as combination of sine waves, and that there's this thing called so I mentioned Fourier, and I don't get into what it is I don't get into details, but I do talk about I and Q. I try to explain. It depends on the group, and some groups got it better than others. They're orthogonal signals and all that sort of stuff, and sometimes I draw a diagram and say this is amplitude modulation with the vector changing, or this is frequency modulation with the vector moving, and that kind of thing. But really, it depends on the group. And so what I would say there is I just play it by ear. And if it gets to a point where things are going to get really complex, then I say you should get the book, look at the references. You're going to have to spend some time studying yourself to really get the nuts and bolts behind this. But you can do it, right? And so I suppose in a sense, you could say, oh yeah, I passed the buck. Maybe I'm passing the buck. But I think what I want to do is I want everybody to have confidence when they come out of there that I can learn this stuff. And probably most hams can, because they had to study to get their license anyway. They may just have to spend 6 months reading the book and thinking and maybe writing their own programs if they have computer skills. That's how I did it. I read the Smith book for 3 or 4 months and developed a bunch of C programs, but I don't tell them that, right? Because they say they'll be afraid because, I don't program, I don't know how to program.
Yeah, I can see that. Thanks, though.
Thank you.
More questions?
What regulatory changes do you think are needed?
I think I couldn't, I've been licensed a long, long time ago, and so I don't know the regulations specifically anymore. But I think if the regulations change to the syllabus contains digital signal processing and SDR and how SDR, they had a chapter, they had a section to that, a section to the requirements, the licensing requirements that talks about bits and bytes and FFTs and digital radio and digitization and quantization and all that sort of, and they can drop a lot of the stuff. They can drop a lot of the stuff that, the old analog stuff that people don't really need to know that well anymore.
So you're thinking mainly of the examination being changed rather than emission specs or anything?
Yeah, maybe I think everything is generated by ITU, and the ITU trickles down to national governments. But in that respect, I think digital radio has been included in the specifications for 30 years, 40 years, going back to allowing packet radio, many, many years ago. But even packet radio packet radio as it's called in amateur radio. Are you a amateur? Yeah, and so basically it's 1200 bit per second AFSK, right? And it's stagnant there for like 30 years, and there have been some projects, like I was involved 20 years ago, 56K, QPSK modems and that kind of thing. But, and that's allowed under the regulations, but I think it's more it's more a change in the licensing. They have to change the regulations so that the students have to know, prospective hams have to know more about SDR, DSP. And that will bootstrap, that will restore, hopefully, some of the innovation. Thank you.